Now, in this question, this is a question on two dimension whereby we have particle A of mass 10 kg moving at a velocity of 14 meters per second towards a stationary object B of mass 8 kg. Now, after collision, this object A is going to change its direction and move at that direction at a speed V at an angle of 30 from the horizontal. And then B is going to move at a speed of 5 meters in that direction, making 41 degrees with the horizontal. Then we are supposed to find, using the principle of conservation of momentum, we are supposed to find the value of V. That's the main question in this particular point. So we are going to apply the principle of conservation of momentum. However, we are going to consider the horizontal component of the momentum. So in this case, something I want you to visualize is that even if we're talking about this object A here, after collision, this object will be having a horizontal momentum in that direction. Yeah, it has a horizontal momentum in that direction. And also B that we have at this point, it has a horizontal momentum in that particular direction. So we can be able to work out the momentum in that direction, but we are going to resolve into the horizontal component of that. Remember, the horizontal is acting in this particular direction here. So we are going to say momentum before collision is equals to momentum after collision. Momentum before collision in the horizontal direction, momentum before collision in this case is going to be only the momentum of this object, because it's the only object that was moving. This was at rest. So that's going to be 10 kg times 14, and that will translate to 140 kilogram meter per second. That is the total momentum before collision. Then momentum after collision, remember this object will be moving that direction, and also this object will be moving that direction. But both of them have the horizontal component. And remember, if you are having an object, a force acting that direction, let's say we have a force acting that direction at an angle, then we can be able to resolve the force into a vertical and horizontal component. So which means that if this angle is theta, then F in the horizontal direction is going to be F cos theta, but the vertical component will be F sin theta. So in this case also, we are going now to work out the momentum in that direction, but we are going now to find the horizontal component of that. Now, after collision, this object is going to hit this object B, and B is going to move in that particular direction. Remember, as it will be moving this direction, it will be having a horizontal component in the x-axis. So meaning, from this aspect, if a force is acting in this direction, that way, then if there is an angle it's acting at, this becomes the horizontal component, and this becomes the vertical component. So the horizontal component of this force is going to be F cos theta, and the vertical component is going to be F sin theta. And also, if an object is moving at an angle that way, or a force is moving at an angle that way, then there is an angle it forms, beta, with the horizontal axis. Remember, we can form a right angle at this given point, right? So which will mean that if this is the force we have that goes that way, then its horizontal component in this direction is going to be F cos beta, and the vertical component in the y direction is going to be F. Find the momentum in this direction. So you can say the momentum of B is going to be equals to what? Is going to be 8 kilogram times the speed at which it moved in this direction. So that's going to be times 5, which is going to translate to 40, right? But now we want the momentum be in the horizontal direction. So if we are having our momentum as 40 at this particular point, the momentum in the horizontal direction is going to be 40 cos the angle that it's making with the horizontal axis. So we can say that momentum of B in the x direction is going to be 40 cos 41 degrees. We also need to find the momentum of A after collision, because they collide. A moved at that point in that direction with an angle of 30 degrees. So we can say momentum of A in that case is going to be, the mass of A is 10 times V. That is the speed at which it moves in that direction, and that's the speed we are finding. But we need also to find the momentum of A in the x direction. Remember, A is going to be moving at 10 V in that direction. So the horizontal component of this momentum is going to be 10 V cos of that angle, and our angle in that case is 30. So we're going to say this is going to be 10 V cos 30. So we have momentum in the x direction and also momentum of B in the x direction, and that is actually after collision. And then we're going to apply now the law of conservation of momentum, and we shall say that momentum before collision is equal to momentum after collision in the x direction. So we're going to say momentum before is equals to momentum after. But at this point, we are considering only in the x direction. So this object was also moving in the x direction. So what was the momentum in the x direction? In the horizontal direction, its momentum was 140. So this is going to be 140. But this one was at rest. It wasn't moving before collision. So we shall say plus 0 is equals to momentum of A after collision in the x direction. We have gotten that it's 10V cos 30 plus momentum of B after collision. It went this way, but we resolved to the horizontal component, and we got this 40 cos 41. I'm going to say 8.66 V plus 40 cos 41. That translates to which value? 30.188. So this is going to be 30.19. Then we can now say that 8.66 V is equal to 140 minus 30.19. Then divide by 8.66, divide by 8.66. And of course, we are going to have these two cancelled, and therefore our V is going to be what? Our V is going to be, we can now work it out, 140 minus 30.919 divided by 8.66. Working out this, we are going to get 12.68. 12.68 as the velocity in meter per second. Now, sometimes in exams you wonder, in which accuracy am I going to give my answers? But if you look at the question, the way it's given, velocity was given correct through two significant figures. So meaning you also give the accuracy in which they have given the answers. So we're going to say our answer is going to be 13 meter per second as the speed at which B moved in that particular direction. If you have gotten value from this particular video, consider subscribing so that anytime we are going to upload a tutorial like this, you'll be notified. See you in the next video.